Good afternoon, everybody. Assuming you can hear me, right, Sandra?
Yep, I can hear you. I can see your slides.
All right, great, thank you. I just want to talk a few minutes. Often asked is the question, how much livestock is there in the Maumee watershed? How much is that increasing? What is the contribution of manure phosphorus to the watershed? So we've spent some time looking and trying to count the amount of livestock in the Maumee watershed. And the methodology we use for this is using mostly the Ag Census. The Ag Census is a product that's put together by USDA every 5 years. So the 2017 census, was conducted in 2017, but was issued in April of 2019. Sorry, I got to chase the cat out of the room. So using the Ag Census, livestock numbers are reported by county. So when we then go to cut that up, we cut it up by area. We basically prorate the county by the acreage. So for example, Hancock County, where Findlay is there, 74% of the acres in Hancock County are in the Maumee watershed. So we would take the livestock numbers from the census and take 74% of that and assign it to the Maumee watershed. It's rough, but it's probably the lacking a better method. It's what we used for this estimate. Another limitation of the Ag Census is it doesn't necessarily report all information or all data for a county. So it tries to protect the privacy of operators. So if there aren't very many operators of a specific type of livestock in a county, it won't report that. So you can't identify, Bob Smith has 100 cows because he's the only person with cows in Williams County. That's not a realistic example, but what is realistic is with the poultry numbers, we tend to have very few poultry operators and they tend to have a lot of chickens. So in some counties, we can have a few poultry operators, but they could have millions of chickens. And that doesn't necessarily get reported in the census protection. So what we can do at ODA is use the permit numbers from the Division of Livestock and Environmental Permitting. So we assume that a lot of the poultry in the Maumee is permitted, or the large majority is permitted. So we can take the census numbers for swine and cattle and add in the permitted numbers for poultry and try to get to a better estimate of livestock in the Maumee. And with that, this is an estimate going back to past 4 censuses, going back to 2002, 2007, 12, and 17, showing an increase in the amount of animals in the Maumee over that time period. So this is kind of normalized by species, so it's in animal units, and then each color on the bar shows the various types of agriculture. So we estimate over the past 20 years, 88% increase in animal units in the Maumee, using both the census and our permitted numbers. And to give you some perspective on that, if you go back further, this is a look at animal units from just the census, looking at just cattle and hogs. This doesn't include poultry because the problems with poultry reporting, and we don't have permitted numbers before 2000. But if you look at cattle and hogs and just the Maumee, you can see that in the early 2000s, we were probably at a long-term low and have seen an increase since then. So we're not the only organization that's undergone an effort to estimate the amount of livestock in the Maumee. The Environmental Working Group tried to do an estimate in 2019. They had a little bit different methodology. They looked at aerial photography, looked across the basin, looked for barns or confined feeding operations, looked at the square footage of those, multiplied it by a stocking rate, and tried to estimate the amount of livestock in the Maumee. So their methodology is a little bit different than ours, where we're looking at the census and the permit numbers. But this table here shows their estimates versus ours, and I'd say we're in the ballpark. As far as we somewhat agree on the amount of livestock in the Maumee. And now if you talk about how much phosphorus then is being produced by that livestock, we can do that, and we have the benefit of having some manure samples, both through the Division of Livestock Environmental Permitting. They require their facilities to sample manure, and then we also have manure samples from our watershed in distress in Grand Lake St. Mary's. So we can kind of multiply the concentration, average concentration of phosphorus in manure by the amount of animals we estimate are there, and come up with approximately 5,000 metric tons of manure phosphorus are being produced in the Maumee watershed every year. And to give you an idea of how much phosphorus that is, that's probably less than 20% of the annual crop need across the 2.3 million acres of cultivated cropland in the watershed. And so as we look at this, we do see an increase in livestock. We see, an increase in manure phosphorus being generated, but we typically think that manure phosphorus is replacing commercial fertilizer phosphorus. It tends to be a one-to-one replacement there. And we can see that in some of our fertilizer numbers. IPNI tracks fertilizer application. And so as manure phosphorus applications increased, commercial fertilizer application is decreased proportionally. And the bottom paragraph on this slide, the environmental working group, their analysis concurred with that. During this time period from 2000 to present, animal manure rates are up, while commercial fertilizer rates are down, and on average, phosphorus application is level. And we see that too with some research that's being done in average soil test phosphorus across the region. UB Dayton published this this past year, where they do a survey of soil test phosphorus, and they see the average soil test phosphorus level in the region has been declining. We don't see evidence in soil test phosphorus that there is additional manure or buildup of phosphorus fertilization. Then the next question we often have with manure is, is the phosphorus in manure more susceptible to loss than commercial fertilizer? If we are seeing more manure for P out there than commercial fertilizer P, is that a problem? Is it more susceptible to loss? And the International Joint Commission looked at this issue in 2018, did a summary of the research, and basically found that there are no significant differences in export of phosphorus based on manure or commercial fertilizer. We also looked at this question when we revised the 590 standard. So we had a working group that looked at the 590 this past year, and part of that, we looked at some of the research, and there is some out there that shows that manure is actually less susceptible to loss and runoff than commercial fertilizer, due to the fact that manure has some organic phosphorus in it, maybe less water soluble, less susceptible to loss than commercial fertilizer. And with manure, there is a risk, that risk can be mitigated with incorporation, and that is why we choose to promote that as one of our H2 Ohio practices. Incorporation can reduce the risk of both manure and fertilizer phosphorus loss. So that's the end of that information. I see that we already had one question from Steve Davis pop up about why the big difference in cattle. I think it's probably because they're counting barns. The environmental working group, I think, was counting facilities or roofs, and may not be counting some cattle that would be in lots or smaller places. And I think there's a little bit of overlap here in dairy cattle and what the census calls cattle. Some of this cattle may be replacement herds for dairy, may not be milk cows, but could be replacement heifers or new cows that would be counted as cattle in the census, but may be counted as dairy if you were to look at the facilities. So I think there's a little bit overlap there.
All right. Thank you very much, Matt. I'm sure, again, this new information will be valuable as we move forward. I do want to get our second presentation in this section going, which is talking about using these kinds of manure and animal information in the SWOT modeling. What can we do with it? What are the benefits and limitations of it? And so I think I saw Jeff Cast. Jeffrey, are you here? And I see also at one point Jay Martin was, so I wasn't sure which of you was going to speak first.
I'm going to be giving the presentation.
Okay, excellent. Go ahead, Jeffrey.
All right, give me 1 second to try to open this PowerPoint. All right, can you see the PowerPoint in its regular mode?
Yeah, it's coming up now.
Okay, great. All right, so good afternoon, everyone. So I'm going to be briefly discussing some of our recent modeling work, examining manure's role on discharge water quality from the Maumee, as well as some ways in which we've used information from ODA as well as from the Ag Census to improve our modeling efforts and our understanding of manure management in the region. So first, this is just going over some of the recent work. This plot on the left shows a result from our recent multi-modeling project, which I know a few of you on this call are intimately familiar with as being part of our stakeholder advisory group. But what this plot shows is the impact of manure phosphorus in our models. So we're looking at total phosphorus in the dark gray and dissolved reactive phosphorus in the light gray. And the average load reductions by removing manure phosphorus from the model. And what we see from this, from across these five SWOT models, about 6 to 7% of our total phosphorus or dissolved reactive phosphorus was attributed to manure applications between March and July, between 2005 2014. Now, as this project was ongoing, some of us at Ohio State were developing a newer SWOT model of the watershed, in which I was primarily focused on looking at ways to improve how we represent manure management within our SWOT model. And in this process, with collaborations with ODA's Division of Livestock Environmental Permitting, I examined manure management plans, annual reports, as well as inspection reports from these permitted livestock operations within the watershed to get a better understanding of exactly how manure is being managed from these facilities. And this plot in the center here shows one of those results of liquid manure application timing of when these facilities applied manure on fields they managed in 2014 and 2015, as opposed to when they said they plan to apply it within their permits. Now, data such as this, as well as some other information from these documents, from these facilities, was then used to drive manure management improvements in our newer or improved SWOT model of the Maumee watershed. And so with this newer and improved model, I looked at the contributions of various phosphorus sources within the watershed to get a sense of exactly, or to get a sense of the estimate of how much manure was contributing to downstream phosphorus losses or inorganic phosphorus fertilizers or point sources, etc. And so this plot here shows that result. And what I've highlighted or have boxed in this red here is our result for the no manure P scenario. So similar to our multi-modeling project, we removed manure phosphorus from the watershed, and we were able to get an estimate of its impact. So what we found here is for both total phosphorus and dissolved reactive phosphorus, again, in the March through July period, we saw about a 10% decrease in phosphorus losses or phosphorus loading from the watershed that's attributed to manure. Now, to go into some of the details of how I've used these data from these permitted livestock operations to improve how we represent manure management within our model, there's a few ways we've done that. The first relates to the timing of when we apply manure within our SWOT model. So based off of the data of the annual reports or inspection reports from these facilities, we have a sense of when manure was applied on fields managed by the operations. And so we were able to create a distribution of dates in which manure was applied within the watershed from these facilities, and then transfer that to our SWOT model. Now, we've also were able to constrain distance. Manure generated on a permitted livestock operation, or a calf here, as I'll probably just refer to it from now on. We see based off of maps of land use agreements that these facilities have with other operators or fields that they manage themselves. There's a distance constraint due to economic reasons, for instance, of how far manure can travel. And so we use different distances for swine or dairy manure generated on these facilities in our model. And so the map here on the slide shows an example of one of our swine facilities. So that square represents the location of the livestock barn, and then the blue oval represents the about 1.5 mile radius of which that manure generated on that facility from those livestock could be applied within our model. And third, and I think really importantly, we established or created new manure nutrient compositions that we applied within the SWOT model that are based off of manure nutrient analyses as reported by these facilities to ODA, based off of nutrient analyses taken of the storage pits located on these facilities. And so we were able to use these more localized manure nutrient compositions as opposed to just a general manure nutrient composition for swine, for dairy, for poultry, for instance, that was just generally available and loaded onto the SWOT model framework. Now, although that we've been able to improve how we've represented manure management within our watershed, there are still some challenges as well as some opportunities. So I've classified these challenges into two groups. The first being temporal and spatial scales. So over time, and as we've seen in the previous presentation, and just based off of national trends, we see that livestock populations, as well as the number of confined livestock operations, have increased over time. As not only nationally, but also particularly within the watershed itself. And we know that the U.S. Ag Census is taken once every 5 years, and then released 2 years after it's taken. So as Matt showed, although the 2017 Ag Census was taken in 2017, the results weren't available for the public until April of 2019. And then also with this Ag Census, the smallest scale at which we are able to access this data is at the county level, which can cause some issues of trying to determine livestock population counts, particularly within the watershed, as not every county in the watershed is fully within its boundaries. Now this leads into our second big challenge, which I consider livestock source. And the first of this would be manure that's imported into the watershed. So we do know that there is some poultry litter that is imported into the watershed to be applied. However, for my own looking, I found a report from OEPA in 2010 that gave an estimate of the tonnage of poultry litter imported into the watershed, but I was not aware, or I'm not aware of any other source that looks into that. So that's one potential challenge of trying to figure out how much manure is being imported into the watershed, where is it going, how is it being applied, etc. Our next challenge with regards to livestock source looks at the management practices of smaller livestock operations versus those in the permitted calves, those that are inspected annually by ODA. There's a big gap in knowledge of those operations. And third, even within our permitted calves, there are some knowledge gaps as it relates to manure that's transferred through distribution and utilization. So we know based off inspection reports who's taking that manure, where's it going, when is it taken, from what storage structure, and then accompanying manure nutrient analysis that manure contains. And then from 2016 and on, I believe there's also indication if that person is a certified livestock manager or not. But so based off of these last two bullet points, I found that there was a gap in knowledge of about 80% of manure phosphorus management within the watershed, which is quite considerable. But even with these challenges, there are a good number of opportunities. The first, which is something that Matt talked about and something I've also done with the methods that I've used for this modeling work, is to utilize the data from these confined animal feeding facilities within the watershed in conjunction with the data from the U.S. Census of Agriculture to generate yearly trend lines or yearly trends and variations in the livestock population numbers within the watershed. And then we can also collaborate with certified livestock managers or certified fertilizer applicators to gain a better understanding of where manure is going, particularly from manure transferred through distribution and utilization, as well as from these smaller livestock operations, and then how it's being applied as well. So main takeaways, our simulations shows that manure contributes about 10% of the March through July total phosphorus and dissolved reactive phosphorus loads from the watershed. And I would note that this is a conservative estimate. There are opportunities to further improve how we represent manure management in our models, and we have done so already, utilizing data from the Ohio confined animal feeding facilities, which is great and really important. But there's also a good number of challenges as well that we face in furthering our understanding of manure management and how we can best simulate it in our models. And so here it's just a list of references that I've talked about, or I've shown results for if you're interested in those papers, the first three, and then the fourth, done by Anna Postel, talks about the development of our newest, what we call the field scale mommy swap model. So if you want to get into the nitty-gritty details of how the model was created, you can look at that. And I'll be happy to take questions, or if you want to get access to the papers. If you send me an email, I'll be happy to send a PDF along.
All right. Thank you very much, Jeffrey. That was great. So we're already over by several minutes. So we are going to allow a couple of questions and shoot to end in about 5 or 10 minutes. Remember, we've been providing, a lot of folks have been putting their contact information in the chat. So you can all feel free to circle back and ask questions if yours does not get answered. So Matt, there's a couple of questions here about your presentation. You addressed Steve Davis. Is there any way for you to know from the information you've looked at? Santina asks, are the increases occurring in higher densities? Is there more CAFOs or more smaller operations?
And I guess I would say it depends what your definition of a CAFO is. I think if you use ODA's definition of a calf, a permitted operation, it depends on the species. I think we see a lot of the increase in poultry in the watershed happening in permitted calves. I'd say almost 100% of the new poultry is permitted. And on the opposite side of the coin, a lot of the expansion we see in swine is happening below the permit threshold.
All right, and Sandy Ben has asked a question again with the 150 parts per million, et cetera. And Sandy, we've addressed that repeatedly, including in the domestic action plan comments. I'm going to skip over that one for now because I feel like that's been answered multiple times in other arenas. Let's see. And then Kari is asking, could ag census data for animal operations be used by Ohio EPA to estimate the portion of the NPS load attributable to manure sources in the Maumee nutrient TMDL? Paul, if you're still with us, is that something you could?
I'm here. Yes, it can. I would say it's not required to. US EPA doesn't require us to break down point and non-point sources, especially non-point sources, to that level of detail. We're not quite there yet with the TMDL process, as we kind of outlined this morning. We have to get through our next couple steps of the TMDL before we know how it's all going to look. But certainly we are very aware of Jeffrey Cass and Jay Martin and Margaret Kalsick's work. And we've been in many communications with them on how they're incorporating the reality of how manure is used in fertilization in the Maumee.
All right. Thank you, Paul. Again, Sandy, your point about that there are reports suggesting that there's high phosphorus soil phosphorus test amounts close to the operations. We don't have data on that, and you can see, you know, OACI does not have that information either. I think the way that Jeffrey is attempting to address that with some of the modeling is about the best we can do with that. And we do intend to continue to further, you know, they're working on further developing their model, and we will continue to be looking at that issue and how it plays out in the watershed. All right, you said that 10% was a conservative estimate for manure P loading in the Maumee. This question I think is for Jeffrey. Can you clarify if it is conservatively over or underestimating the amount?
Yeah, so I'd say it's conservative. It's a conservative estimate on the low end.
Conservatively low, so you think it's possible it could be more?
Yes.
Okay.
Yeah, potentially it could be higher, but.
Do you want to also, Jeffrey, I don't know if you want to try to do a better job of answering the previous question. Are you looking at how that soil test phosphorus might be higher in the vicinity of the operations? Is that part of what your modeling is looking at, and how?
Yeah, so that's something that I think we're going to be doing in the future. So within our SWAT model now, we have soil test phosphorus values initiated for the agricultural lands within the watershed, but we have a value for the soil test phosphorus that's based off an average of soil test phosphorus across the watershed. So one thing that we're going to be doing in the future is how do we vary the soil test phosphorus values across the watershed within the model, and that would be one thing that we could look at further once that process is done and that data has been integrated into our model.
Excellent. That should be very useful. All right. So I have us at 12:40, and we do want to be mindful of time. Joy, do you have closing words to wrap us up?
Well, I see that we had one more comment, Scott Higgins. Why don't we let Scott ask his question or make his remarks, and then we can go ahead and close out for today.
Okay,
yeah,
let's do it.
I would really appreciate that. And thank you very much for the last two presentations. I'll just say this on behalf of the livestock community. Our livestock operators are very conscientious. And while people don't know exactly what their numbers are at every farm, what we do know is that they are working with their TSPs, their crop consultants, and they're doing everything that they can to lower the levels of phosphorus on their farms. One of the things we've been talking about for many years now, and we've got to consider this, the nutrients and the value of manure within our ecosystem are undervalued. The benefits that it has on soil health, soil development, water retention, and overall crop growth are undervalued. However, I got to give tremendous credit to Ohio State University Extension, Glenn Arnold, as well as Greg LaBarge for helping to drive focus to the benefits of manure. We're working as an industry to increase the level of understanding of the benefits of manure so that economically more and more of our grain farmers will seek to secure nutrients from manure first before they supplement with commercial fertilizer. What that will help do is help us distribute the nutrients from within our ecosystem more broadly on acres that need it to increase overall soil health and contribute to a better ecosystem. But bottom line is this: we want to improve our overall ecosystem by using the nutrients within it first and require less from coming into our ecosystem. That will contribute to a reduction in phosphorus going into Lake Erie. Thank you.
All right, thank you, Scott. So I want to extend a huge thank you to everyone who put together a presentation and everyone who provided comments and questions throughout today's session. We've gone over our 4 hours, and that's a long time, but it was a really good discussion on a lot of fronts. There's a lot of work evolving, as you have heard today. And so I think we've touched on some good items, and we will continue those conversations. Again, encourage folks who did not get to ask their question to reach out directly to the presenters. We are going to work to make the recording of today's session available on the Lake Erie Commission YouTube page. I think that's right, Sandra. So that you can go back and check information. But otherwise, again, we really appreciate the dialogue this morning. So Sandra, anything else you want to add?
Just that we appreciate you all for coming, bringing your questions. We expect to try to continue to keep the lines of communication open, and we are looking forward to your input and appreciate your attention.